Hello everyone, my name is Varun, and in this presentation, I'll be talking about my text mining project, which is on genetically modified organisms. This project mainly focuses on the debate regarding the positive and negative light about GMOs. Now, moving on to the introduction, what are GMOs? Genetically modified organisms are the plants or animals whose DNA has been intentionally altered by scientific methods to exhibit desired traits such as increased yield, enhanced nutrition, or resistance to pests and environmental stresses. While biotechnology promises to address global challenges like food insecurity and sustainable agriculture to farmers, public opinion still remains deeply divided over the long-term health benefits or causes, long-term health causes which could affect which could be caused due to GMOs and environmental impacts of GMO foods. This project analyzes a diverse set of text sources, that is, from news articles, social media posts, especially from Reddit, and expert commentary to uncover the main themes, associations, and sentiments shaping today's debate about GMOs. Now, what are the main research goals of this project? The main research goals are to classify public sentiment. That is, I plan to build models to automatically identify whether the text expresses pro or anti-GMO opinions. Another goal is to uncover which words or phrases commonly appear together in GMO discussions. And one more goal would be to reveal main themes. That is, what are the main topics which are being surrounded in today's GMO debate. And finally, the goal is to evaluate and compare different machine learning methods like clustering, naive Bayes, decision trees, SVMs, and neural networks to determine which one model performs best to classify sentiment so that it could be in future it could be implemented. Now, who's going to benefit most from this research? There are many different benefactors from this research. The big one would be policymakers who want to understand the public concern about GMOs and companies involved in biotechnology and agriculture who are looking to align their message regarding their use of GMOs to public sentiment. And one more would be a researcher studying the social impacts of scientific innovation and also advocacy groups, that is both pro and anti-GMO groups who want deeper insights into public disclosure. Now, the data which I used for this research or the project is collected from various sources. One source is from newsapi.org, where I retrieved around 292 articles related to GMO terms, that is GMO and anti-GMO terms from different news outlets. Another source was a Reddit API where I collected for 500 Reddit posts or comments from different subreddit threads which were discussing about GMO or anti-GMO related terms. And the final one was through web scraping, where I just scraped one article from Medical News Today. The article name was Genetically Modified Food. What are the pros and cons of it? And finally, after collecting data, it was cleaned and later it was converted to a 1,000 dimension feature matrix of TF IDF vectorized format. We can see over here from two different images, that is raw and clean data. The raw data, which I collected from three different sources, was overall in JSON format. And after converting the data frame to feature matrix, it is converted to this format, as you can see on the left over here. It is labeled and it is in a TF-IDF vectorized data frame format. And it has 1,000 features. Now, when it comes to exploring the data, I have used two different methods, which is unsupervised machine learning and supervised machine learning. In unsupervised, my first method was to use clustering. Now, for clustering, I have used two different ways, which is k-means and hierarchical clustering. For k-means, produce three different clusters. That is, k equal to 3 has shown the best results. Now, this shows that the topics where the data was divided into three different clusters. For example, one cluster was focusing on health concerns, another one was about economic benefits, and a third one was about regulatory or policy debates regarding GMOs. Now, when it comes to hierarchical clustering, you can see on Over here from the dendrogram, we can see that it is divided into four different clusters. These clusters were strongly ranging from four different sentiments regarding GMO, that is strongly anti to strongly pro-GMO. So this, you can say that hierarchical clustering gave a high-level segmentation, while k-mean exposed more nuanced subgroups when it comes to clustering the data or dividing the data into different subgroups. Now moving on to another method which I used was association rule mining. Now for association rule mining, I have particularly used only the 500 digit uh, comments or posts which I had to uncover various word pair associations that appear most frequently in GMO discussions. You can see over here there are three different network plots of the rules which were sorted by confidence, lift, and support. And the frequent patterns shows that GMOs were mostly associated with food terms. This emphasizes the food's central role in debates which were taking place in GMO. And some rules like reject science had 100% confidence, which was highlighting the strong skepticism towards GMO's research. And these patterns confirm that labeling debates, health concerns, and food safety issues dominate the public disclosure about GMOs. Moving on, another method which I used was topic modeling. Especially, I have used topic modeling with LDA over here. Now, topic modeling was used with around 800 rows of data to divide the text data which was available into different topics to know that which topics were actually surrounded regarding GMOs. No, I have found three different topics classifications over here. One was regarding health sustainability, another one was product and technical, and the third one was market and policy. The topic one mostly focused on the heart of benefits versus risk arguments, whereas topic two focused on specific GMO products like purple tomato, golden rice. So it was about product and technicality of it. The third one was basically discussions regarding regulation, trade, and global impact of GMOs. Now, these topics show that our goals are perfectly aligned with the topic classification. That is, health concerns, agricultural innovations, and public debates are the backbone of GMO's debate and conversation in this day. Now, moving on to supervised learning, where the labels are present. I have used various methods here as well. Now, coming to the first method which I used was naive Bayes classification. For naive Bayes, I have particularly used multinomial naive Bayes. So this model was trained on TF-IDF features of 1,000 features especially to classify the sentiment into four different sentiments. Classify the labels to four different sentiments. That is, it is strongly or mildly pro-GMO or strongly or mildly anti-GMO. So I have particularly used a 70-30 train split over here. So after training and testing the model, I have found that the model achieved a testing accuracy of around 58%. So the accuracy is pretty low over here because we had a limited amount of data. So this accuracy could be improved in future if the data was we had more amount of data. Now, from this confusion matrix, we can see that this model particularly detects strongly anti-GMO, but it somewhat struggles between mildly classes. Mildly in the sense, I mean, mildly pro or mildly anti-GMO classes. Now, naive Bayes is a fast, and it is easy to interpret, so it makes it as a strong baseline model for real-time sentiment monitoring in social media streams, especially in Reddit posts. Now moving on to the next model which I used, which was decision trees. For decision trees, I have used three different trees over here. That is the trees with default depth, one with maximum depth of 5, and one with maximum depth of 7. I have built three different trees to see how the depth was affecting the GMO sentiment classification. Now, the best model which I found was with the depth of tree with a default depth that is with maximum depth. The accuracy which I found was around 52%, that is 51.7 to be specific. The shallow tree fell down to an accuracy of 44%, that is depth with depth 5, and the deeper tree with depth 7 fell to around 43%, which shows that as the more complex trees overfit to noise, The tree visualizations highlighted that GMO labeling and health were some top splitting features, giving clear and human readable rules for why a post is classified as pro or anti-GMO. Now, over here as well, we can see this the accuracy was pretty low over here because the data was pretty limited. Now, compared to Nye base over here as well, we can see that strongly anti-GMO and strongly pro-GMO classes were being classified better compared to the mildly anti-GMO or mildly pro-GMO classes. So we can say that these rule-based insights can inform targeted messages by pinpointing the exact terms that sway public sentiment. Moving on to support vector machines, I have used three different support vector machines over here, which is one with the linear framework, one with RFP, and one with polynomial SVMs. So all were used with various Cs. So the best performing model which I found was with SVM with RBF kernel with C equal to 10. It had an accuracy of around 62%. Now this is slightly higher than the linear and polynomial kernels. Now, SVM excels at handling high-dimensional TF-IDF data, and non-linear RBF kernel captures intricate class boundaries with minimal tuning. So over here as well, we can see that strongly anti-GMO, strongly pro-GMO were the classes which were being classified better compared to others. Now moving on to the final method which I used was neural network classification. For neural network, I have used a simple feed-forward network over here, which was implemented with two hidden layers in Keras to predict the four different sentiment class labels. So we can see from this, we have achieved an accuracy of around 58% over here. And we can see from model accuracy over epochs, the training accuracy was increasing as the epochs were increasing, but the testing accuracy was also increasing, but it flattened to around 60% accuracy as the epochs were increasing. This model was trained with around 20 epochs. So we can see that neural networks offer flexibility to incorporate word embedding and deeper architectures to further improvements. Now, coming to the final conclusion of this project. So the final conclusion was, you can say that as we have seen from various models, strongly anti-GMO or strongly pro-GMO texts were easily classified uh, thanks to the unmistakable language cues which were present in the text. Also, another observation which was made was mildly pro and mildly anti-GMO classes remained challenging for the models to classify as there were no easy cues for the models to identify. From association rule mining and topic modeling, it was consistently highlighted that labeling debates, health risks, and specific crop innovations and policy trade issues are the core to GMO disclosure or debates. And while classifying models, the support vector machine with RBF kernel was found out to be the best model, which had the highest accuracy among all the models which were tested. So we can say that SVMs perform best on high dimensional text data. Now, these insights which we got can guide GMO communicators and policymakers to tailor messages emphasizing clear and science-based health information where confusion is highest. So it can help various people to know where they can focus their message clearly based on the people's concerns regarding GMOs. Thank you.